Recording. Okay, so in terms of the breakdown of the exam, you need to study everything that's in the exam scope. So it's all the work covered in the semester. All right. So we are doing question 9. Okay, so it says, so let's just check. The UML factory of the future is in the process of automating most of its production processes. So you must basically designing communication between the devices. So there's a controller, there's a controlled, there's a command. So you have to use the command design pattern. So the controller is responsible for invoking commands. So it will be an invoker. And you have decided that, oh yeah, so there's that. So now you need to provide a UML class diagram to your colleagues to give them a clear picture of how you would apply the design pattern to the problem. So the classes for the different kinds of objects that need to be supported are shown below in the form of Java code. So we have a controller device. So let's just open here. Okay, so let's do that. Okay, so we have a controller device which has a command as an attribute. And then we have execute command, which basically will tell the command to execute. And then we have a controlled device which has a state called is running, amount of work done, starts, stop, do work. We have the interface for command, which is execute. And then we have a start command, which has a controlled device, which basically, when you call execute, it calls device.start. So the rest of the class does not matter. And then you have a stop command, which stops the device. You have a do work command, which tells the device to do work. All right, so let's look at the command design pattern. Okay, so command design pattern. Okay, so here basically we have a client, we have our concrete commands, we have an invoker, we have a receiver, and we have an abstract command. So let's draw those classes. So in our case, these are all concrete commands. This is an abstract command. That is a receiver. That is an invoker. So let's do that. So we have a client. Then we have an invoker. So in this case, the invoker has some properties. So it has a command and it can execute the command. So let's create a command. So command. Then we have a method called execute command. execute command which does not return a value. Yeah, so that's the invoker. And then we have the abstract command. So so that should be called command because the invoker knows about an abstract command. So let's just check. Yes, so it's called command. So it's the abstract command here. So in this case, then we have command, which is an interface. And then what does a command have? Well, simply has the execute method. So execute, which is void. So apply. So that's just all that there is to the interface. And then we have the receiver, which is a controlled device. And the receiver has certain attributes defining its state. So is running and work done. So it seems like the value is set upon declaration. So is running, Boolean, false, and then work done. Ugh. An int 0. Okay, and then operations, start, stop, do work. Start. And there's a stop method. And then there's a do work method. Yeah, and then so that's the receiver class. There's nothing else here. So let's just check. Yeah, straightforward. So, and then we have our commands. So let's just create space for all of those classes. So we have 3 different classes. So I'll just put all of them here. So let's just relook at this. So the client has to know about the command, has to know about an invoker, and has to know about the receiver because it creates all of them. So we have a start command, which basically has execute, and it has the controlled device. Okay, so all of them look the same. So let's just do that quickly. Okay, so stop command. And then we have the other one. And we have the same thing. Okay, so that's that. All right, and then we just need to have the class relationships. So there's that. There's that. And then there's this one. Yeah. Okay, so and then the invoker stores a command. So that's aggregation. Doesn't really matter. So aggregation or composition, you still get your marks because it really depends on the use case, right? So on the default, yeah, it's abstract command. Yeah, so I suppose you could say it's abstract command because it only exists inside of the invoker. But you would still get your marks even if you said aggregation. Okay, so, and then, so that's that. And then, so client, has to know about an invoker. Has to know about each command. And this one as well. Oh, so it's this one. And then it has to know about the controlled device as well. Yeah, so that's basically your class diagram. What do you get marks for? Controlled device, 1. So all the classes, 1, 2, 3, 4, 5, 6, 7. And then the other 8 marks come from the class, the methods and the class relationship. So abstract command has execute, that you get a mark, so that's 8. Execute exists in all of the commands, that's 9. Invoker has a command inside of it, so that's 10. There's the line for aggregation, that's 11. And then the client has to know about an invoker, that's 12. And then all the commands, that's 13. And then this is 14. And then having all of those methods is 15. So the mark allocation differs, but usually, like if you do most of the stuff, you get 15 marks. So this is just a rough guide. But the most important thing, so this obviously would get a mark. So the interface implementation, you need to show that. You need to show the dependencies between the classes. You need to have the methods that are shown here. So you need to have all of these methods here in all of those classes and so forth. And yeah, so that's basically the answer to this question. Okay, any questions regarding this? Okay, so if there's no question, let's move on to the last question of this paper. So this was a cold code section. So basically, we need to provide Java source code for the following problem. So we have an entity called Our Music, sells musical instruments, allows potential buyers to test the instruments inside of the store before buying them. An instrument is either acoustic or digital. Digital instruments must always be connected to power so that they can switch them on and play them. This uses a lot of electricity, and the manager wants to know the minimum voltage consumed by each digital instrument. So the code below provides more information on the musical instruments. So we have musical instruments, and those are all the attributes. You have so an acoustic instrument here has a get material method, and then a digital instrument has a get minimum voltage, right? So all the manager wants is the minimum voltage. So that's all we care about. We don't care about anything else. So we need to create a write digital instruments info, which accepts an array list of musical instruments and a file handle. So the method will write the ID, name, and minimum voltage of each digital instrument to the text file using automatic resource management. So how do we find the ID and the name? We go back to the code. Here's an accessor, and here's an accessor for the name, right? So pretty straightforward. Okay, so just check something. Yeah, so just to make sure this is text file handling, right? So as you can see, to the text file. So very important. Okay, so public write digital instruments. Set the file. Let's put it file. Yeah, and an array list. So, and I think it accepts an array list of. So let's just check. An array list of musical instruments. So array list of the base class. Oh. Okay, sorry about that. Okay, so now we need to so let's just complete this method prototype. So instrument. Okay, so the first thing is we need to create a print writer. So print writer. I think this is, yeah, so writer. Oh, automatic resource management. New print writer. It's a file handle as a parameter. Catch. Okay, and then what we need to do is, so for each, what we need to do is we need to basically check if it's a digital or acoustic. So if instrument is an instance of digital instrument, then what we need to do is we need to write that to the file. So you can do this however you like. So string ID, I think it's a string. I may be mistaken. Oh yeah, it's an int, and that is a string. So int ID, that would be instrument. Oh yeah, so I need to cast it into a digital instrument. Well, it doesn't, oh yeah, because I need to get the minimum voltage, so I have to cast it. So digital instrument, I is, or we could just use this, instrument, digital, digital instrument. Yeah, and then so after that, then instrument dot get ID, and then we need to get the name. So instrument dot get name. And then we need to get the minimum voltage, which is a double, probably. Yeah. Okay, so we need to get that. Okay, so okay, so that's the minimum voltage. And then now that we have everything we want to write to the file, we can write to the file. So it's really up to you. You can convert this like to a string first. And then so it'll be like ID, do something like this. So ID so the other thing would be the name. So name, and that would be a string. And then the minimum voltage, that would be a double. Yeah, so that would be that. So this just means 2 decimal places. And then skip the line. So end the line. Or we could just make the print writer do that. So this would be the ID, name, min voltage. Yeah, and that's that. All right, and then so after that, then we write that to the file line. Yeah, and then this would insert the end of line character at the end, right? So you could do it either way. You could just say print, and then you would include it here. That's still fine. Completely up to you. All right, so any questions regarding this? Okay, so pretty straightforward function prototype. So you get a mark for this. Taking a file as a parameter, get a mark for that. Array list, the other parameter, just do this. Still long, okay. So you get a mark for that. So creating a print writer, so for the try block, you get a mark. Creating a print writer, get a mark. Oh yeah, so using automatic resource management, you get a mark. Musical instruments, so for the for loop, you get a mark. Taking the instance, you get a mark. making the conversion, you get a mark. This would probably, so let's see. So all of this would be the same mark. So 2 marks for that. And all of this would be 1 mark as well. Oh no, this would be 1 mark. Well, let's say it's 2 marks. Yeah, so you can get 2 marks for that. Found exception. Don't really get a mark for that. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What else would you get a mark for? So let's see. Yeah, okay. So it'd probably give you 2 marks for this. Well, maybe it would give you 3 marks for all your trouble. Yeah. So then, but eventually you'll get 15 marks. It's always 15 marks. Okay, so that's that. Yeah, so that's how you get your marks for that. Okay, so just before I end the lecture, just a few quick announcements. So remember, practical X late submissions closes at 12. There'll be no extensions because we have to calculate your semester mark. Practical, all the bonus practicals, 12. We can't do anything later than that. Semester test 3 SSA is next week Tuesday at 8, I think. So you just keep an eye on Eve for that. Semester test 2 is next week Thursday. The SSA for everyone who could not write because of the religious holiday. So that will be next week Thursday. Yeah, so that's that. We will get the semester marks to you as quickly as we can. Yeah, so that's that. I think practical X, the marking for that is finished. We're still processing queries, and then you will get your marks for that as well. Yeah, but apart from that, all the best for your exams. Remember, you are writing on the 20th of June. I think it's at 12:30 in the afternoon. Yeah, so arrive early. Don't come with a bag or anything like that. It'll just waste your time and stress you out. Just leave it at the collection facility. And yeah, so all the best. I wish you guys all the best, and hopefully I will see some of you again in honors. Okay, thank you very much. Enjoy the rest of your day.